another good time to be with you to take a revision on some sensitive topics that are necessary to be reviewed before you enter into the exam. It's important for us to note that there are some topics that we need to be careful with because they will involve some diagram drawing, and that is why we may have to review bearing and distance all over again. Quickly today, I want to pick on bearing and distance. And the first thing I want to say about that is there are two types of bearing. There are two types of bearing. Two. The first type is the 3 digits bearing. The example of that can be 082 degrees, 172 degrees, 211, 341 degrees. And of course, you can have as many as possible, but it should be a 3-digit bearing. The second type of bearing is the compass bearing. An example of this can be 48 degrees the north of west, 76 degrees south of east, 64 degrees north of east, and maybe the last example can be 28 degrees the south of west. It should also be emphasized that when you are drawing diagram in bearing, one, we should note that we cannot draw diagram without the 4 cardinal points. You must start your bearing with 4 cardinal points. And another emphasis is that when you are measuring your angle for a 3-digit bearing, you should measure from the north in the clockwise direction. For 82, for instance, 82 will go this way. This is my cardinal point, this is the north, and 82 should also go this way. Of course, this is 82 degrees. Another emphasis that I want to talk about today is when you are drawing diagram in bearing. Remember I said that you always draw with the assumption that you are drawing to scale. All these facts are in our notes. Please, let's go over them. With an opportunity to re-emphasize it, because with a wrong diagram in bearing, our solution will also be affected negatively. So please, it's important we re-emphasize those facts or those points so that we can at least use them when necessary. Under bearing and distance, my students should also remember that there are about 4 different applications that we must go back and check carefully, which are the cosine rule, the sine rule, Pythagoras theorem, and trigonometric ratio. 4 basic applications that will be necessary. Even beyond bearing and distance, you also need it in elevation and regression. So, they are applications that you must know absolutely well. Can we quickly look at this question? Let's write very fast so that we'll also be on the same page. Please let our concentration be here. All right? From a point X, comma, a point says 6 kilometers on a bearing of 037 degrees. 037 degrees. Are we together?
Yes, sir.
To a point Y. To a point Y. Full stop. It then says 7 kilometers. It then says 7 kilometers from Y on a bearing of 068 degrees. On a bearing of 068 degrees. to a point Z. To a point Z. Full stop. Calculate A, the distance XZ. The distance XZ. Calculate the distance XZ correct to 2 decimal places. B, the bearing of Z from X. The bearing of Z from X correct to the nearest degree. Correct to the nearest degree. Are we on the same page?
Yes, sir.
All right. With that, we will quickly look at the first important thing. And the first important thing on this topic is you translate the question into diagram. And at that point, students, I want to warn carefully, let your mind be in what you are doing so that your diagram will not be a wrong diagram. Translate correctly. All right. So we will do that together. I can rub this off now. Okay, let's rub this off so that we can have enough space to manage that question. From the question, the information given to us is that the bearing is taken from which point?
Point X.
Thank you. It's point X. So my starting point is point X. That is my point X. And that point X must have cardinal points. They said from point X, a ball says 6 kilometers on a bearing of 037. Bearing is that bearing, what type of bearing is it? It's a 3-digit bearing. Then is the bearing should be measured in the clockwise direction, and it is just 37. 37 in each quadrant is 90 degrees. 37 is a small part of that quadrant. So you cannot say this is 37. Class, is this 37?
No.
Great. So that is not telling us you are drawing with the assumption you are drawing to scale. So this is my 37. And because it's facing up, I think I should create more space going up. Okay, that is my 37. Okay, and this is point X. From the information, it said a boat says 6 kilometers on a bearing of this to Y. This is 6 kilometers now. And this is where the next point is. This is Y. Yes or no?
Yes, sir.
Okay, from the set, he now said that it's then. It then means that you are not coming back to point X to take another bearing. You are actually doing continuity. That is, if you leave a particular point X, you get to point Y. It is after getting to point Y, you will now think of taking another bearing from point Y so that you can continue your journey. When you see the clause it's then, it is a signal that after taking that movement, you have to take another 4 cardinal points to take the next bearing so that you can get to your next location. All right. It then says 7 kilometers from Y on a bearing of 068. 068 should be a bigger angle than the half of that quadrant, should be?
Yes, sir.
And 7 should be longer than what? 6. This is my 7 kilometer. This is 68. I can still tell them it is 068. And this is point where now? Z. That's point Z. It is forming a triangle. That's a triangular movement. So But after doing that, before you can do anything, you need to work on the information given to you so that you can at least have an angle inside your triangle. Work on the information given to you in terms of the bearing. Using this quadrant, you will agree with me that the remaining angle here will be 22. Right?
Yes, sir.
You also agree with me that the angle here and the angle here, they are alternate angles, so they are equal. Right?
Yes, sir.
The last thing I can see here is that this is 90, so total angle here should be
149.
140.
9.
That is 90 plus 59. Right?
Yes, sir.
That's 149. Thank you. 149 degrees. What is the first question? I'm through with the diagram. This diagram now will give me some marks. I'm through with the diagram. You can see that all the movements, the points that I visited show. It's showing clearly on the diagram. So, they said the first question that you have been asked is the distance xz. Correct to what?
Two decimal places.
Distance xz. Correct to 2 decimal places. I've talked about some applications. About 4 applications. We have the cosine rule, the sine rule, the Pythagoras theorem, and trigonometry ratio. In this problem, something is giving me a signal about a particular application. The angle A, I called it to I told my students sometimes ago that this angle is what I call an included angle. And when you see an included angle, it is a signal that it is only cosine rule that you can use to find the only unknown side in that triangle. Please, students, let's note that it may not appear in bearing and distance. It can appear in any triangular problem. When you see an included angle, what's an included angle? Quickly, I can define that from here. An included angle is the angle that is located in between the 2 known sides of a triangle, any triangle, as the case may be. When you have an included angle, then the only application you should use is cosine rule. So for this diagram, I want to find this distance. I'm calling it k. What is cosine rule? Cosine rule is a squared is equal to b squared plus c squared minus 2bc, the cos of a. Obviously, if I'm using what is on the board to place my values or my letters, this will be small y, this will be small x, and this will be small z. Right or wrong?
Right.
Okay, with that, I can now say this is y squared is equal to x squared plus z squared minus 2xz, the cos of y. That is telling us we are using cosine rule directly for this problem. With this, y squared is what we need, is equal to x squared is 7 squared plus z squared is 6 squared minus 2 times 7 times 6, the cos of 149. Cos 149, obviously, it should be a negative value, and this is 49 plus 36 minus what? 84 into minus 0.8572. Thank you. 8572. Okay, the minus and minus there is telling us minus times minus should be addressed, which will give you plus. This is what? This is 85 plus 84 into what? 0.8572. Yes, finally, this is what? 85 plus 72.1848. Okay, adding those two numbers together, you have this is still y squared. To get y, we need the square root of 157.0048. Somebody help the class. 12.53 as much as possible. Let's reduce the same Barbarian talks in. So please, I want response from a single person as much as possible. 12.5 what? 53. I think we are okay with 53. 02 is not affecting it now. So, but are we asked to put it to any say 2 decimal places? So before we do that, then that means you need to say 02 first. Then you now say your approximation is 12.53 kilometer to 2 decimal places. Are we still communicating?
Yes, sir.
Great. That is the distance between distance xz. So I can now say this is xz. The next question there says what?
Bearing of z from x.
The bearing of z from x. Sometimes ago, we treated getting bearing of a particular location from somewhere. And my simple analogy all the time has been that I want a student to help me get a bottle of Coke from the fridge. Obviously, the common sense there is that you have to go to the fridge first before you get the bottle of what? Before you get the bottle of Coke. So if the question is saying the bearing of x from z, the signal is you must go to z first. That's the first thing you do. When you locate the point of interest, our point of interest now is where? Is where? Z. That's the first. Please check it. I've even written out some steps on how to find bearing to my students, and it should be in your notes. This is a good time to call your attention to that. Please go back and check them. I said my first point on getting a bearing from a particular place is locate the point of interest. Our point of interest today is where? Z. When you get to the point of interest, I told you again to do what? Draw the 4 cardinal points. There, you can see I've drawn the 4 cardinal points. After drawing the 4 cardinal points, I said the third step is you move from the north in the clockwise direction until you get to the line, joining the 2 points of consideration together. Are we still on the same page, class?
Yes, sir.
When you move in the north, and when you move from the north, you are moving in the clockwise direction until what? Until you get to the line that is joining the 2 points of consideration together. After doing that, the total movement you have done is the bearing. That's all. You now analyze that movement. If you see my movement, I can see this shaded part is 180.
Yes, sir.
Yes or no?
Yes, sir.
The remaining angle A is what I'm interested in. And I can be very sure that this angle is alternate to this one. Right or wrong? Right. The angle A is also equal to this angle A because they are alternate angles. So if I need this theta there, it's the same thing as this angle. And this angle, I can find the small angle inside a triangle. It means my theta is equal to 37 plus alpha. Yes or no?
Yes, sir.
Okay? But the bearing they are asking us to find, I can make a statement for the bearing. The bearing is the bearing of what? Of x. The bearing of
Z from X.
is it z from x?
Yes, sir.
Oh, is the bearing of z from
X.
we have to go to x now. Do you have to go to z? No. get a bottle of Coke from the fridge, where do you go to?
The fridge.
The bearing of what?
Z.
The bearing of Z from where?
X.
Where are we going to? X. Come on. X. So, this is where you are going to. Even though, eventually it will. Please, you have to read your question to me carefully so that we follow, and that is telling us you should read the question carefully. If it is the bearing of Z from X, the first place you go to is where?
X.
X. Is it Z?
No.
So, it's X. If it is X, we are going to X. After getting to X, draw 4 cardinal points, that is done. Then move in the clockwise direction from the north. In the clockwise direction, you are moving until you get to the line, joining X and Z together. The 2 points of consideration. This total movement now is our bearing. That means our bearing of Z from X should be equal to 37 plus alpha. Can I rub this off now, class? Can we rub this off now?
Yes, sir.
Okay? With that, so that we can have space for the second question, let's quickly rub it off and we'll be able to manage that second question effectively well. With that, we have our challenge of getting only angle alpha. This will take us to another application because already the value of y here is what? Someone?
12.5.
Yes, 12.53 kilometer. Okay, if it is 12.5 kilometer, I can look at that diagram now with the information of y. That means I have one angle and its corresponding side. I want to find an unknown angle with a known side. That is sine rule. Yes or no?
Yes, sir.
So using sine rule, which is A over sine A is equal to B over sine is equal to C over sine C. For this, it will be 7 over sine alpha, which is equal to 12.53 over sine 149. It's the same thing as sine alpha over 7 is equal to sine 149 over 12.53. Making sine alpha the subject of the formula, you have 7 times sine 149 over 12.53. Are we still on the same page?
Yes, sir.
Okay, what is sine 149? 0.5150. Okay, over 12.53. That will give you what? So sine alpha will now be 0 point something. Yes? 0.2877. Is that a general position?
Yes, sir.
Okay, alpha will now be at sine 0.2877. What's that?
16.72.
16.72 degrees. Okay, the bearing that we are now looking for, the bearing of Z from X will now be 37 plus 16.72. What's that? 53.72 degrees. If this is our final answer, then if you leave your answer this way, students, because we are dealing with a 3-digit bearing problem, your answer must always appear in 3 digits. So you will lose mark here. Even though you have made good effort and your calculation is correct, but the final answer should be written as a 3-digit answer. So my final answer should be 053.72 degrees. Any reaction, any question? To the nearest degree. Thank you. To the nearest degree will now be 054 degrees. Okay? So, any question, any observation, you want to any clarification, that's something that we need to also quickly do on bearing and distance, taking our mind back to one or two applications, some fundamentals in bearing and distance. Are we okay, class?
Yes, sir.
Are we sure we have the right understanding of what we are talking about?
Yes, sir.
Any question?
No, sir.
Okay, can we appreciate ourselves? That's a good one. Thank you for